In this video, I'm going to review how to write an equation of a linear function given 3 points. We only need 2 points to write an equation of a linear line. So I have the option to choose any 2 of these points. I don't want to work with decimals or fractions if I don't have to, so I'm going to choose the first and the second point. This is the first point, so I'm going to label it as x1, and the second point x2, y2. Now I'm going to write the equation of this linear line in y equals mx plus b form. So let's first start by figuring out what is the slope of this line. This is the equation for slope of a line. I'm going to replace each one of these variables with parentheses. So y2 is 5, y1 is 2, x2 is 4, x1 is negative 2. 5 subtract 2 is 3, 2 negatives make a positive, and 4 plus 2 is 6. Now this is not wrong, and if you wrote 3 over 6, I would accept that. It can be reduced down to 1/2. So y equals 1/2 x plus b. Again, if you leave it as 3 over 6, I will not count it wrong. This is just the reduced form of 3 over 6. Now I need to identify what is the y-intercept, and I can use either one of these ordered pairs. I'm going to choose to use 4, 5, because neither one has a negative sign. This is an x, this is a y, so I'm going to replace the x with 4 and replace the y with 5. Half of 4 is 2. To isolate the b, I will subtract 2 to the other side, and now I have my y-intercept. So my whole goal is to write an equation that contains the provided ordered pairs. Y equals, my m again is 1/2 or 3 over 6, and my y-intercept is 3. Now how could I check to make sure that it does work for each one of these? Well, I could substitute in an input value of negative 2. So half of negative 2 is negative 1. Negative 1 plus 3 is an output of 2. Okay, that works. I could do the same for 1 and 3.5, or even 4 and 5. I substitute in 4. Half of 4 is 2. 2 plus 3 is 5. And it would work as well. It would work as well for 1 and 3.5. If I substitute in 1, half of 1 is 0.5. And 0.5 plus 3 equals an output of 3.5. Let's practice another. I'm provided with 4 different ordered pairs that all belong to the graph of a linear function. And so I'm going to choose 2 of these. Which 2 I choose is up to me. I'm going to choose these 2. 1, they don't have decimals, and 2, they don't have negatives. This is the first point, x sub 1, y sub 1, and x sub 2, y sub 2. Now let's start by identifying what is the slope of this line. Always y is on top, so this can be y2, y1, x2, x sub 1. Okay, so y sub 2 is 4, y sub 1 is 1. X sub 2 is 10, x sub 1 is 5. 4 subtract 1 is 3, 10 subtract 5 is 5. And whether you leave it in this form that can't be reduced or you prefer to use a decimal, it's completely up to you. So if y equals 3/5 x plus b, the last step I have is to identify what is the y-intercept. Where does this line cross the y-axis? So I come up here and I choose any one of these ordered pairs. Doesn't matter which one I choose. I'm going to try 5, 1. I'm going to replace x with 5 and y with 1. A common mistake when students do this is they ask themselves, like, how do I do the calculations here? This is really a 5 over 1. So when I multiply, I go 3 times 5 is 15, 5 times 1 is 5. And I know that 15 divided by 5 is 3. Now to isolate the b, I'm going to subtract 3 to both sides. And I now have b is equal to 1 subtract 3 is negative 2. Here's my b. Here's my m, and I can write an equation. Y equals 3/5 x minus 2. This is an equation of a linear line that models these data points, and we can make sure we did it right. For instance, let's start with 10. If I plug in 10 here, so I'm going to replace this with 10 just to show you how it works. Okay, 3 times 10 is 30, 5 times 1 is 5, so I have 30 over 5. Well, 30 divided by 5 is 6, and 6 subtract 2 gives me an output value of 4. It works.